Everybody, thanks for coming along to this ETP seminar, or webinar, I should say. I'm Dave Jenkins from Heriot-Watt University. I'm the theme leader for the Energy Efficiency in Buildings theme under the ETP banner. So that's the theme that's running this webinar today. This is the second webinar we've carried out in the recent cycle, but there will be more in the coming months, so do keep an eye out. Let's move my slides on. So hopefully many of you will already know what ETP is and what we're about. So the Energy Technology Programme is an alliance of 13 Scottish higher education institutions, all engaged in world-class energy research with world-class facilities across the whole of Scotland, with some of the organisations listed there. Energy is obviously a very broad theme. In fact, it's a collection of lots of different sub-themes. And so that's how we're structured within ETP. So we have 12 different themes within ETP. If you go onto the website, you can hear more about the activity within those themes and who's leading those themes. Today, we're looking at energy efficiency in buildings, which is led from Heriot-Watt, but involving a number of universities on our steering group. But of course, with energy, although we like to try and neatly silo this work into different pots, it's obviously a lot more complicated than that. And there's lots of crossover between these themes. I think we understand that any challenge requires us to understand sometimes all of these themes or some of these themes and understand how the links work. The key thing with ETP, though, is not just to link these different themes, but actually to link the academic expertise with places where we can point that academic expertise in industry. So it's building up and strengthening those links between industry partners and the academic resource that we have within Scotland. And that will be reflected in some of the presentations that you see today. So underneath the energy efficiency in buildings theme, we have a steering group. So as I say, there's always this temptation to silo work into neat boxes, but we recognize things don't work quite in that way. But this does help us target different expertise towards different organizations, different companies. So underneath energy efficiency in buildings, we're looking at environmental controls, led by Fan Wang from Heriot-Watt. Smart buildings under Hadi Larajani in Glasgow Cali University. Also in Glasgow Cali, Rohinton Emmanuel, who's interested in post-occupancy evaluation and overheating. As well as leading the theme, personally, I'm interested in energy compliance and energy performance certificates, both on the modelling side and the policy application side. Julio, who we'll hear from in a minute, who's organising this particular webinar from University of Edinburgh, has been working with historic buildings and future-proofing of buildings, and we'll hear about some of that work in a minute. And that obviously spills over as well into wider discussions around retrofit, demonstration of materials, which John Curry at Napier is also looking at. Also at Napier, Antoine Regius looking at the delivery of heat and cooling. Clearly, heating technologies is a key part of what we're talking about today. And then Laurie McElroy at Strathclyde looking at building simulation and building modelling and all the different things we can do from a software starting point. But as I say, clearly lots of interaction between those sub-themes. So we're very much not trying to silo ourselves too much. There's lots of ways that you can get involved with ETP more generally, and particularly the energy efficiency in buildings theme. So we have an industry doctorate program, first of all. So whether this is an academic with a good idea that's relevant to an industry partner, or perhaps an industry partner has an idea that's developing and you're at the stage where you maybe want to test this out across a 3.5-year PhD project. There's a third model there in terms of the funding. So ETP fund a third, the university will fund a third, and the industry organization will fund a third. So if that's the stage that your idea might be at, then do get in contact with us on that. There's also the Knowledge Exchange Network. So this is a kind of feasibility fund pot where companies can get funding to pay for academic consultancy. The way that works is you would contact us and we would try to effectively matchmake your query with the expertise that we have within our ETP network within the theme. But ETP as well is just more generally as a network, not just events like this, but moving forward, we do have a both an academic contact list and an industry contact list to kind of demonstrate that the amount of work and the amount of research that's going on in this area within Scotland. So if you're interested in what you hear today, if you're interested in some of the things that you might see on our website, then do get in contact. Our business development managers, Tom Bent and Ewan Millen, who are both on the call today, would be happy to take any queries that you have, particularly around some of the funding possibilities that we're interested in, but just general questions. Do please get in contact with us and support and get involved with us as a network. So today we're going to focus on retrofit as part of this webinar. So I'm not going to spend too much time talking about this because we have some excellent speakers lined up to get into the guts of this in a bit more detail. But from a top level, we know that the required future pathway for buildings to hit our carbon targets is extremely challenging. So this graph from the Climate Change Committee's 6th carbon budget shows you the carbon emissions that have been assigned to the UK building stock. And what's particularly noticeable is round about sort of 2004 to 2011, we did seem to be making progress. If you look at year-on-year data for the carbon emissions of the building stock, it is a little bit noisy. It does jump up and down for a whole range of reasons. But we started to see a fairly steady evidence of progress in terms of the reduction of carbon emissions within our building stock. But if you then compare that to the required action, that steep gradient of change required from 2020 to 2050, then you really do get a feel of the scale of action required. So this Climate Change Committee report runs several different future scenarios. That's what those multicolored lines are. They all relate to different technologies or different policy applications being put into place. So they're different futures, but they all require that big slide down to a zero carbon future by 2050. And of course, looking at that graph, looking at those historic emissions, the dashed black line, the obvious question is, well, what happened at this point? I don't put exclamation marks into my PowerPoint slides lightly, but I think this warrants it. So, as I say, we were making progress up to around 2011, 2012, and then we've hit this really frustrating plateau. And there's various reasons for that. We can't pin it down to just one thing. But what we do know is around about 2012, there was a big change in the way that retrofit was being funded. All scales of retrofit, but particularly around residential buildings. There is a parallel as well with non-residential buildings. But for those that were around and active at the time, 2012 saw the introduction of the UK's Green Deal, also paired with a supplier obligation scheme, ECO. And that was pretty disastrous for insulation rates, in particular within UK homes. There was a complete nosedive, as you can see in these graphs. Loft insulation, cavity wall insulation, solid wall insulation numbers have never been particularly great anyway, but that also dropped from 2012. We also saw some reductions in new heating technologies being put into homes as well at the same time. So we're still really in a period of trying to recover from that period. If we think about what was happening in that previous graph and the scale of action that was required, around about 2011, 2012, we were just getting to the point where perhaps we were building up a bit of momentum to even start to think about that scale of change. Obviously, the frustrating thing for academics like myself, but certainly industries involved with this area, is that momentum has been lost somewhat. So we need to kind of get the engine started again, and that's going to take some time. And time isn't really something that we have. But to put a slightly positive spin on this, there was a time not that long ago where we were actually achieving considerable levels of retrofit within our building stock. Somehow, as you know, and we're seeing policy getting reshaped as we speak, so there is some positivity there. I think we're seeing some of the most challenging policy around buildings in terms of future policy and future policy planning that we've ever seen. The challenge now is to try and put that into action with real buildings, and as I say, try and get back to where we were in 2012 and then kick on from there and really accelerate that action to meet some of these really challenging carbon targets that we have for our building stock. So I shall finish there. As I say, do please get in contact with us if you want to know more about ETP generally or the energy efficiency in buildings theme. But I will stop and I shall pass you over to Julio, who's going to be caretaker for the rest of this webinar.
Thank you very much, Dave, for that introduction. That was excellent. Yeah, welcome everyone to this Existing Buildings Retrofit webinar. My name is Julio Bros-Williamson. I'm a lecturer and Chancellor's Fellow at the University of Edinburgh. And I'll be kind of chairing most of today, and hopefully we can go through these excellent talks and presentations in a swift way. We will have presentations from industry, from academics, and also local government representatives, and there'll be a mixture of 1 and 2 speakers in each talk, so a good kind of variation of thoughts and perspectives. And that will, roughly last about 15-20 minutes for each presentation, to give us some space and time for some questions and answers after that. So hopefully people can add some questions in the chat. I think that's the best way to do this. There is a facility if you want to unmute yourself to ask a direct question, you can do that. I will give 5-minute kind of warnings for the speakers, if that's okay. Just I'll kind of interrupt very quickly, and just really to give us that time for the questions at the end. So our first speaker is a combination of an industry and academic project. We've got Sandy MacGregor, who's a regional director of Energystore, and myself, who conducted this research on this project. The title is Alternative Thermal Upgrades of Single Stone Walls Using Blown-in Insulation. So I'm glad Sandy's on screen, and what I'll do next is share my screen. If I can. So you should all be able to see the presentation. And I'll hand over to Sandy first, and I'll continue in another slide. Sandy, over to you, please.
Thanks, Julio. Thanks. Yeah. So thanks for the time today, and so we could talk about our project that we completed along with Julio, and was funded by the Construction Scotland Innovation Centre. We're looking at the thermal upgrades for single stone properties for blown-in insulation. So just to get started, we'll give you a quick introduction just to who we are at Energystore. If you can move the slide just on, Julio. So just give you a quick snippet of who we are. So we're the UK's largest EPS bead manufacturer. We've got 6 manufacturing facilities across the UK and Ireland, and we've got 100 install companies roughly across the UK and Ireland who install our material, and it goes into roughly about 1,000 properties per week across the different variations. When we look at what our key product, our core product, is called Energystore Superbead, and it's predominantly used in standard masonry construction in both new build and retro. If you could just go to the next slide, Julio, please. But it's also applicable for new build timber frame, the party wall, and as a result of the project that we completed along with Julio for single stone properties, and predominantly what we've done so far with that is on tenement properties. So just to give you a quick overview of the project from our side. If you could just move on to the next one, Julio. So when we were looking at setting up the project, the real driver for us was looking at the Scottish market, having a look at what were hard to treat properties in the market, and with tenement properties making up about 27% of the urban housing in Scotland, and traditionally have always been expensive and difficult properties to upgrade. we looked at this to see whether we could come up with a solution that would work in these properties. So to do that, we looked at creating a solution and then doing the thermal testing pre and post to see what the real impact on the buildings were. So really what we wanted to get was a new install methodology and technique to install these properties and conduct the real life testing for both U-value, air tightness to show the real impact that it could have on these, and then look at getting a measure that was approved, third-party accreditation, come with a 25-year guarantee to show that the measure was both beneficial for the property and help the homeowners to have a more cost-effective heating system within the property, considering these are traditionally quite cold and hard to heat properties. So I'll just pass on to Julio, who will give you a bit more detail from the academic side.
Thank you very much, Sandy. Yeah, this was a very interesting project, which I was lucky to be part of. Really we were, as Sandy was explaining, a project that was looking to expand a bit of the work that was already been developed by ourselves while I was at Edinburgh University with Historic Environment Scotland. It was looking to kind of extend that sample size. We did focus directly on these existing solid walls in tenements and other archetypes, looking to add insulation at key areas. And in most of these single stone buildings, there is a cavity just behind the linings, the dry linings. Now, it could be your existing kind of traditional lath and plaster linings in various kind of conditions. And if the property's already undergone some kind of retrofit, it might be your plasterboard dry linings, more modern versions. So the idea was to inject expanded polystyrene beads into that cavity and use the super bead product by Energystore as a kind of an example and a case study here. So we tried to use the high-end product and thermal performing silver bead that super bead gives us, and tried to inject it directly behind that lath and plaster cavity. We had a series of partners, Energystore definitely as a client and provider of the beads themselves. We had installers in place who were familiar with the buildings and were able to deploy the workforce to do this work. They were Everwarm, who are a kind of wide Scottish contractor in existing buildings and retrofits. And it wouldn't happen without the housing associations that took part: Williamsborough in Paisley, Castle Rock, Edinburgh in Edinburgh, and Hillcrest in Forfar in Angus. So a wide variety of building types, all housing, but different problems and different scales of the problem as well. Looking at ways in which we can talk to the residents and also see the technical aspect of the installation and also the measurement of performance. So as I mentioned, one of our goals was really to expand that data set. Some of the work done previously looked at maybe 2 or 3 examples. So here we had this opportunity to extend it to 10 properties. We also wanted to include the use of air permeability testing and, to a certain degree, condensation buildup inside the cavities before and after the insulation was injected. Some of this work was omitted in previous studies, so it's good to include this and to see if there's any impact on those tests from the work done. So looking at really having that technical approach of the installation, as Sandy was mentioning, having a prescribed methodology that could be taken forward by other contractors. It was one of the aims as well. And looking at that expanding over to other building types was also quite important. So looking at some of the project challenges, there were, through the surveying of these properties, with the 10 properties to begin with, a quite varied approach in terms and varied set of results in terms of the build-ups of these walls. One would expect that all single stone buildings would be the same, but that is not the case. We certainly have variations in cavity depth that have an impact, obviously, on results. And also the state of these cavities is not always as pristine or as well executed. So it's important to understand that there'll be differences there inside of the depth of the cavity within the same wall. So that was something that we encountered. Getting access into the properties was also complicated. There was at the end, with the help of the housing associations, that kind of better approach and understanding of the occupants of the work that was going to be done, both in the installation and the testing. But we did have a couple of unoccupied properties which were quite good for the actual installation process. But when it was to control the heating for the thermal testing, it proved to be a bit of a challenge there to maintain temperatures and to actually control it in a better way. So yeah, that was kind of some interesting challenges there. I mean, these photographs show you the sample of the archetypes on the left-hand side, and then some stages of the actual survey of the cavities and the equipment that was used for the bead injection into the walls and the cavities beneath. In terms of results, and looking at some of the tests that we did, we were really focusing around these pre and post testing. First of all, to obtain a baseline in terms of how it performed, how that wall performed, and then moving on to how the intervention actually came around and what the impact was of it thermally. So I mentioned the tests, two main ones really. We looked at 15-day pre and post testing of in situ U value tests and sensors onto the walls directly where the walls were going to be improved and injected at pre and post, and also looking at air permeability of the whole house or the whole flat in this case, and looking at ways in which there would be any advantages in terms of uncontrolled ventilation and infiltration. And the condensation risk analysis, looking at interstitial condensation, having humidity and temperature probes at different depths of the cavity and the wall. So we aligned to British standards and testing techniques for doing these in a good way. So just some brief comments around the results. We were very lucky to get a good set of results in terms of U value and a kind of continuous approach and monitoring during what was required. We had pre-intervention as a baseline, a region of 1 to 1.4 watts per meter squared Kelvin. And then at post-intervention, where we had the beads already injected, the same period and same location of measurement, we had a reduction down to, in some cases, 0.45, 0.6 watts meters square Kelvin. And that created a mean improvement of around 63% around the 10 monitored dwellings in terms of U value. which is very successful. In some properties, it came down to even lower than that, to an increased improvement. So that was quite important there. But it was very much dependent on that cavity depth. We did have some that were 80 millimeters in depth, some that were up to 130 millimeters in depth. So obviously that impacted on the results and the thermal resistance and the impact of the beads. In terms of the air permeability and air leakage, we did monitor 10 out of the 10 dwellings, mainly to do with access. And results really were very much quite low impact, we felt. There were some properties that only had the full external walls injected with the beads, and others that had only one of the walls selected because of access and problems with the tenants. We had three dwellings with full bead injection, and we observed a reduction of 2 meter cubed per hour meter squared in air tightness values, which is from a 15 to 13, which is quite impressive. But unlucky in terms of those that had very low kind of injection, in terms of only maybe one wall achieved. We had a very small, as expected, reduction in air tightness there. And in terms of overall impact of a flat with this intervention and with this retrofit injection of beads, there were some reductions in energy experienced through modelling using standard assessment procedure, looking at remodelling the energy efficiency of the flats. We looked at savings of up to 3,500 kilowatt hours, which was roughly about £130 per year in bills and around 750 kilograms of CO2 reduction. So considerably an impact for such a low intervention, low impact intervention in this case. So briefly over to Sandy again, if I can, and then I'll come back to wrap it all up.
Absolutely. So whenever we looking at the solution that was developed during the pilot, our main focus was to get a viable measure that we could get accredited and approved and would show real thermal improvement to the building. But when we're looking at what other benefits the solution has, the cost of upgrade and using this sort of method as opposed to traditional methods to upgrade tenements such as traditional IWI, this solution offers a considerable financial benefit as it's much lower cost. There's much less disruption because we're installing to the walls that are already there. They may have to decant for short periods, but even then the installs can be completed in half a day or less to be able to install the properties. You're not reducing any of the space within the building as you may be with some traditional measures. So some of the properties that we installed in the buildings where the rooms could be quite small, to have put IWI on there might have just made them a bit too tight, whereas you're installing it, so no reduction in space. You're getting a good thermal uplift. Obviously, it's dependent on how big that void is behind the lining, but we are getting a good thermal performance uplift in that space. And when we're starting looking at EPCs, in some of the pilots that we run, we're getting EPC uplifts of 2 to 7 points depending on the wall makeup. So there's a lot of benefits to this, and when we're working with a number of housing associations, it's obviously helping towards, we've got EASH targets coming in there. It's a potential option in properties that may be either impossible or extremely costly or difficult for them to improve. So we certainly think we've managed to develop a solution that offers an alternative to what's out there at the moment. I'll pass back to Julio for the next step.
Thank you, Sandy. To wrap it all up, in terms of future work and how we want to maybe expand this type of work, a lot of it is of what I talked about was in domestic settings. We want to maybe expand that over to the non-domestic sector. to look at similar cases in terms of solid wall and that cavity behind the lath plaster or plasterboard. We definitely want to do some more interstitial condensation testing for longer periods. The work that we did in this project was for short spaces of time, but nevertheless, the work that we've done in the past with Historic Environment Scotland has shown very short periods of condensation that tend to dissipate that condensation quite quickly. But I think it has to be done in a wider scope and a wider set of cases and examples. We do want to have we are developing an academic paper out of this work, and we do want to deploy it around some of the work I'm doing with the University of Edinburgh and some of their campus buildings. So that will be an excellent opportunity there to test and trial this further. Just on the note there of the academic paper, we are looking at the engineering and history heritage paper to be showing some of the results in that journal. And I invite anyone who's relevant to academic reporting to use this as an example, as a good journal to publicize some of your work. And finally, thank you very much. I appreciate this is a kind of short presentation and not so much detail, but the full report is available from the funder. They have it on their website still for anyone who wants to read further. And these slides will be shared so you can access this link quite easily. Thank you very much. I think we'll move on to some of the questions, and I can see some of them in the chat. A question here from Bruce in terms of how the joists ends altered and protected to prevent rot. In terms of, I mean, I wasn't involved fully in the installation, but there were holes added to different sections within the walls, and because this was a kind of low intervention solution, there weren't any protection directly onto these joists. The injection would go through into the cavities from the inside, and these cavities, and these holes, sorry, would be sealed directly after being filled with the injected beads. So the beads actually have a kind of adhesive within them, and that acts as that kind of binder between the beads, but it doesn't solidify completely. So it still manages to let air pass through it. So it's not a closed cavity. We're not closing that. So the chances of rot appearing again are quite low because that ventilation is still maintained. Sandy, I don't know if there's anything there you want to add.
No, I was just going to say the solution is breathable, so you know any moisture build-up there has got the ability to dissipate in there, so there's no additional protection added. But with the makeup of the material, it's breathable to let any moisture pass through and dry. So that's how that one's dealt with.
Thank you there. Another question by Christoph. Have these properties been surveyed again after the testing, I guess, the initial 15 days? In terms of the work I have done, no, they haven't. They haven't been retested. This work was done 2 years ago, just before the pandemic started. I think it is worthwhile going back to them. There is a bit of an issue in terms of access to these. They're vulnerable kind of groups of people and occupants, but I'm sure there'll be an opportunity to kind of revisit this, and definitely around the condensation would be interesting. I do understand that the Housing Association is keeping a close eye on any complaints or anything appearing in terms of condensation, so I'm sure if that appears, we would be made aware of that.
Yeah, and some of our installers have worked on with the same housing associations that we've done these initial ones on, and there's not been any feedback of any negative problems there.
A question here, thank you, Sandy. A question here from from Fang Wang. Is a layer of air gap normal in the tenement buildings? Yes, traditionally you would have the lath and plaster layer and an air gap just before the stone rubble or the stone ashlar, depending on the type of tenement. But generally there was that gap and that cavity behind for ventilation purposes and the rest. So obviously uninsulated from since built and originally. So there was that kind of passage of air and ventilation. So Andy, what are you going to say?
We saw a bit of variation across the properties. You know, there's a survey methodology that goes with it before any install to make sure that the property is suitable. There is always usually the air gap in some properties. It's too small for install. Other ones it can be very big, you know, 200 mil plus. But there is an install methodology, but we do see a gap always there, just sometimes varies in size and depth.
Thank you. Bruce has got another question. If it's blown beads, how can properties be rewired in the future without beads being disturbed? The surveys done before any injection were quite extensive in these properties and would be within this installation manual and procedure. So if the property required any rewiring, it would be done before injection. Post-injection and post this intervention, I think a lot of the installers were identifying where these new wires were and the rewiring is. So there would be an understanding and labelling of this installation being done for future tenants or for future owners.
What wiring was also any wiring within the walls that there was bead installed in, the wiring was put in conduit as well. So the wiring was protected, and if you were going to retrofit, you'd be able to most likely be able to do that in its current because of the conduit could be accessed. If you needed in future and there was major intervention required that you would need to go in, you could cut a section of the beads out to access the rewire. The best thing to do would then be to get the bead reinstalled, but with the wires being in conduit, and then the cabling can be changed usually post install.
Dave has got a question. How might the super bead product sit within current future subsidy schemes? I think that's one for you, Sandy. You look into that in a bit more detail.
Yeah, so in Eco 3, we got this solution recognising innovation measure to be as an internal wall or solid wall product. There wasn't as many able to get done during Eco 3 as we would have liked because of COVID, and the housing associations had restrictions on work completing. This will be rolled into Eco 4, so it will be available as an innovation measure in Eco 4. So there's funding there applicable for the solution. So we expect a greater number to be done in Eco 4. So there is funding available for this type of measure.
Thank you. Moses has asked further to Bruce's question in terms of wiring. I think that's been talked about. We can talk about it further in terms of isolating and the wiring for safety. On to another question from Fan. What was the reason when you tested instrumentation? What was the room humidity? Was it a kitchen living room? I mean, it was a living room, and again, we couldn't do an extensive testing throughout other rooms. And in terms of the season, it was a winter season, so all these tests were done during the heating season. So that was when we kind of obviously logged external conditions against internal conditions over a kind of occupancy period as well. A question from John Ferguson in terms of the heat and obviously walls close to chimneys. Any issues there? I mean, these properties We're not, as far as I know, close to chimneys. Most of the external walls, at least the ones that were only single wall, etc., didn't encounter that.
So
Sandy, I don't know if you...
Yeah, as part of the install method and in the survey when we were doing the initial study, we decided not to install any properties that had open fires. You know, it was a conscious decision made because there's potential, the potential risk is not necessarily the right word, but there's more likely to be issues because of with that there and with ventilation, because ventilation is a consideration for us as well. So with any buildings open fires, we didn't install, and we made a decision that there was too much variation in there.
Question there from Kamar in terms of the cavity depth and that being a determining factor. Yes, it is, and we, as I mentioned, we did have some smaller cavities, in terms of 80 mil up to 130 mil, which was quite an extensive cavity, and those really determined a lot of the results. And again, this is a small sample. We're talking about 10 properties with varying kind of complexities. So there were those changes, but it was also the cavity depth within the wall. So at times we had 100 mil within that same wall, and then it kind of reduced down to 80. So that obviously brought in those complexities. Rand talking about the link for the report. Yes, there might be there. I checked it yesterday, and it does go into the PDF directly still, but I'll double check that when sharing the slides. And then finally, I think that's all we have time for in terms of thermal bridges. To minimise risk, especially around window reveals. I mean, this was looking at the bulk of the wall itself, where the cavity was present. Around window reveals, there would be another type of intervention to maybe rigid insulation around these to kind of get close to the window and to kind of address those issues. So in terms of wall, extensive wall, the bead was used, and in other situations, other interventions would be used. Okay, well, I think we've got, that's all we've got time for this presentation. Thank you very much for your questions there. I'll stop sharing, and thank you very much, Sandy, for your input. That's great.
Thanks, Julio.
And I'll introduce the next speaker. Next, we've got Dr. Dimitris Theodosopoulos. He is a colleague of mine. He's a senior lecturer and tutor at the School of Architecture here at the University of Edinburgh. And he also heads and delivers the MSc in building conservation. So there's a great deal of knowledge there and expertise and skills and a lot of projects he's been involved in. His title is Complexities of Restoring and Maintaining the Heritage of Buildings. So hopefully he'll touch on some of these issues that have already been kind of mentioned, but I'm sure there's others. Over to yourself, Dimitri. Thank you very much for your talk.
Thanks very much, Julio, and for all of you attend. I don't know how much I will have something brand new to say, similar to the original research that Julio and Sandy, but also the next speakers are going to talk about. So I thought of focusing more on good practice in the retrofit of similar buildings, and I can see that the theme is tenement, Georgian buildings, housing projects, historical housing projects in Scotland. So what I was thinking of doing is giving a short overview of some conservation challenges that we have, some theoretical and practical challenges, a reminder of some topics that we usually talk about at the beginning of a conservation project, and then zoom into some of the problems with the fabric, some of the strengthening and repair problems regarding stonework, typical of Georgian housing, and eventually finally talk about some issues with some areas that have very directly to do with retrofitting, like elements in the roof, but nevertheless can be part of the project, because in many cases I believe any client, any owner would like to see the opportunity of not only retrofitting, improving the energy efficiency of their own walls, but addressing other areas that can be vulnerable. And once scaffolding and an architect or an engineer is appointed, then it is much more cost-effective to deal with such issues. So let me share my screen. On screen. Okay, and we will hear lots of very interesting and up-to-date research on the field, but very often the other side of the same wall looks like that. Okay, so it is very often some of the problems might come not necessarily from the poor makeup of the wall, but in many cases by poor repairs that have happened during the lifespan of the building. And a big culprit we all like to accuse professionals and researchers is the use of cement, a very typical image of patch repairs on eroded wall on the elevation of a not very exceptional tenement block in the fringes of the new town in Edinburgh. This cement, as some of you may know, or you will hear during the talks, very often blocks the passage of moisture from the interior of the building, or it is, let's say, a good shield of an external moisture, but it does not allow the wall to breathe. So a lot of important problems in the energy performance of the building start there. But in many cases, these are often aesthetic and conservation problems. So, and very often, a term that any project might like to satisfy when dealing with the heritage authorities at the local level or national level is to show some conservation credentials that some thought about the fabric has been given in terms of its historic significance. And sometimes, of course, this might be dictated by the listed status of the building. Very often, especially in the technical world where I'm coming from, I'm a civil engineer by training, and I'm specialized in conservation. Very often, the word that these are the words that you will see or hear technical people talking about: minimum intervention, reversibility, like-for-like repairs, pathetic. But often, equally often, we come across situations where these terms are completely challenged. It might have to do with the nature of the problem. And here is a typical range of problems that we see in the east of Edinburgh. Lots of local small to large scale subsidence problems, which might require, in this case, the very large substitution and reconstruction of this bay window. So a big question there is, are these typical criteria, typical mantras even applicable there? Can we have a conservation attitude that is much more flexible, does not really lock us into pointless conversations about what is minimum, what is reversible? Some of these conversations can start from a more sound knowledge of conservation theory. Conservation theory is not something that is taught at the undergraduate level at any of the technical degrees, architecture, surveying, engineering. You have to go to postgraduate courses. You can hear various definitions of what conservation is. It has to do with recognition of the architectural values. And very often, this recognition is mistaken by a quest to return to an original design unit. How the building was when it was built and conceived, and it was meant to be like this. It is a false dilemma very often. Many professionals recognize that, and it is more about understanding the key cultural, historical characteristics in the history of the building, and try to do something with that in more holistic design terms. Of course, when we talk about monuments like this famous Roman monument where many conservation theories were coined, we talk about a much more meticulous research and debate. But even in the more humble Georgian tenements, very often these concepts have some space. Many interventions have happened in the lifespan, externally and internally. And it is a case, the case I want to make is that it is more about a wholeness to reconcile artistic, technical, and cultural aspects that we find. So there's a lot of judgment that should be expected there by the professional who leads the project, and some discussion that this professional have to have with the owner of the building. Very often, it is an issue of an extent of the intervention. How far of the original fabric is still there. And again, it is a strong debate in areas like important historical monuments or monuments with major history or political debate around them. That's an important museum in Berlin, where I'm sure you can tell on the right-hand side how much of the original fabric was preserved and how much of the new one was added, judging from the color and the texture of the elevation. And of course, the left-hand side is completely brand new. And this is also another area of judgment that we need to apply. How much of the original fabric can be set at the front or sit at the back, which means fabric sitting at the back has more of an archaeological value, something that we appreciate more of its value as a witness of the very original face of the building. In Georgia buildings, it's much more worth it to talk about reconciliation, and this is a very well executed project by experienced architectural companies like Hypostyle in that case, with support of the Edinburgh World Heritage. Technically, very, very sound. It is a textbook case, if you like, where stone analysis has happened, where a meticulous study of how much original fabric can be salvaged, where high quality stone masons were employed, where some of the architectural features that were preserved were or restored was done so with lots of care, where an architect was guiding the project beyond, let's say, the individual elements. I argue sometimes how far the irregular, let's say, texture that was left behind by this project is something that gives justice to the original plain lines that William Playfair was trying to achieve over here. But that's a much bigger debate among people in heritage in Edinburgh, so maybe it's for another forum. In technical terms, the easiest, let's say, and technically and theoretically sound approach to do is by stitching back missing or misperforming masonry. And this is where some of the first challenges happen. The challenge to sustain the void of the decayed masonry that you are removing while you're doing that. The challenge of bringing something in material terms compatible with the existing one. The challenge of bringing something which will not undermine the authenticity of what is left. The decision whether this is eventually going to be seen if it's plastered internally or if it's viewed externally. Many important decisions that have to be taken. So a simple mirror substitution with a completely distinct material, like brick on a stone wall, might not be always the easy, straightforward solution to the problem. We have problems with the fabric, much bigger problems. So I will deal with a few of the individual areas, but we never forget the broader picture that all these small problems might be an indication of a bigger structural problem. And the Standing Committee for Structural Safety, SCOS, a few years ago, I think now they call themselves CROSS, published a very interesting report on structural issues in Scottish tenements. And it is about stability, it is about shear deformation, settlement, or the incomplete tying of floors to walls, or wall to wall at the corner, or the tying of the roof, or some roofs might have decayed and start pushing the parapets. This eventually can manifest firstly as energy efficiency problems, because they might cause cracks and might let water in, and they might manifest primarily as concentrations of moisture, but there might be a bigger underlying problem. So, of course, this is where you need professionals, where a client will need a professional to assess the problem holistically. Sometimes the solutions come directly from a careful study of the original fabric, things that experienced professionals may know already, or experienced masons know, because simply have worked constantly into these buildings. Restoring how the walls are tied in a transverse way can be the easiest way to guarantee the stability of openings. In this case, restoring the original windows around, or even the through bond of the structure. So just repeat what good practice you might have found there or in other cases. Often we try to minimize any intervention on the wall by the stone matching technique, which tries to find a compatible visually, but primarily mechanically and materially compatible new stone. And this is often how we take off a small portion of the skin, not a whole block, and we fix it back with in a certain order and with the use of modern clamps. A minimal intervention, just exactly where you need it. And we should not forget that important issues happen also on the corners. So even if the stonework might look okay, there might be much larger forces in place, and the corners, or where floor or a roof meets the wall, might require tying. Some of the solutions can be invasive, even if some companies can guarantee that their epoxies can be dissolved and the whole thing can be taken apart. The effect is much more long-lasting, and it might be more difficult to take it apart rather than adding some more reinforcement if in the future something has proven to be incomplete. A solution that every professional with an eye to tradition would like to test first is to reinforce a depleted wall with lime injections. And sometimes it can be done in a very traditional way, like simply letting gravity do the trick. You fill these very elegant bottles over here with a very fine lime solution, and you locate your tubes every half a meter, 1 meter, and then you let gravity slowly direct the lime grout into any voids, and you expect that if you have placed all these devices close enough, that all voids will be filled. Theoretically and mechanically correct. The problem might be how far you can guarantee that any such voids can be filled, and how well all this lime grout will eventually harden to a desired strength. And that solution, yes, sorry?
4 minutes.
4 minutes, yes. And that solution that, please, let's avoid an easy shortcut in any seismic area, unfortunately, south of Europe, granite, completely reversible, completely respectful for any part of the history of the building. On the other hand, that's the other extreme, very respectable and reversible solution, fiber reinforcements, very much in fashion in many seismic countries in the southern of Europe. Lots of good research and practice is around them. In theory, very reversible. You can simply dissolve the glue that is sticking the mat on the wall, and if you're not satisfied with that, you can apply something better. Moving to other elements in the fabric, we can see not only the load-bearing fabric is vulnerable, but in most cases, actually in Edinburgh, an area that I know better, and in Glasgow, I believe, it is mainly the roof elements and the decorative elements that are much more prone to trigger a intervention. The parapets, the balustrades, the chimneys, the edges of the roof. And unfortunately, these things do happen. Windsor Place, I think back in 2008, this cornice collapsed. And thanks God there were no victims over there. Big blocks fell on the ground. Some of that can be inherently bad, inherently weak. I think that was the problem with this cornice over here. The design was initially quite weak. But of course, these are vulnerable elements on difficult positions, areas that you might tell of the problem right close to the end, that just before failure, areas that are difficult to maintain, difficult to access, difficult to keep an eye on. And any bad past repair practice might have a much bigger effect over there. Some of them, as I said, are inherently weak. That's the scary picture of the network of the ducts in a gable wall that would link the chimneys that had to be there in every room in the 19th century, leading up to the chimney stack that we see nowadays. So the wall is vulnerable inherently, but we often do see only the final part, which is the chimney stack, which is equally very bad, and that's a very typical situation that you can tell only when you move up close. I don't think I have to describe these horrors to too much detail. I think you can tell. And very often, when you carefully, after you put a lot of scaffolding and disruption on your neighbors, that's a situation that you come across. This is the only sound elements that were left, the feathers, as we call them, the divisions between the flues. They are the only ones that are bonded. You can see how easy it was to remove the front face of this chimney. That's an image of the decay as it is given to us, reminded to us at the Care and Conservation Manual published by the Edinburgh World Heritage Trust. Before, halfway, and now, how the through bond of this box has been completely undermined. And some solutions. The important thing is to tie the box back together, use modern techniques with metal pins, metal plates to fix new stone feathers within the chimney and on the facing of the chimney. The choice can be sometimes to completely reface the entire chimney. There is very little of the original fabric that was left intact in its place and worthy to preserve. Old old techniques, cement around it, new techniques, rebuild it carefully. Well, it's not actually a new technique, but it's gaining more and more ground among owners, because good heritage bodies can have word, and they are listening. Back to the cornice in Windsor Street and the aftermath over there. It is a matter of understanding the corbelling that happens there, and that the solution might be completely at the back of this situation. Whether you can think about adding significant weight at the back, or threading down the blocks down to the head of the wall, which is supposed to be sound at the back. So yeah, it is important to understand that. And on top of such cornices, we have another vulnerable element, which is the balustrades. A beautiful characteristic of Georgia and Edinburgh, this noble crowning of many buildings. But there is another aesthetic, not necessarily aesthetic reason behind them. There is the edge of the roof, which is sometimes a bit scruffy and has to be hidden. It is an important edge over there. It is the gutter that collects all the water from the roof and has to be shed somewhere. So it is a big system that is hidden over there, and decay of the balustrade might signify decay on other elements as well. But balustrades are also to be looked after, because they might cause problems with public safety. And you can look also another horror over here, a missing one. Plus its cornice, it has been completely vulnerable. Some of them can be cemented. There is good LED flashing at the back, still in place. But as I said, it is an edge that has to be looked after. Some architects might think of complete replacement. Some other ones might think of partial replacement, saving some money from the clients, but it requires skills. And eventually, the point I would like to make towards the end is that all this knowledge is good, all this sensitivity is good, but one, we have to look after horrible problems from the past, problems of bad practice that have caused fatalities. The big event, the big accident of 2000 in the Ryan's Bar, but it highlights as well the fact that we still need not only good knowledge, but also experienced masons, well-trained masons, masons who can not only learn from these mistakes, but also develop good practice. And I think Moses is going to talk more about it in his talk. Thank you for listening.
Thank you very much, Dimitris. That's very interesting. We often talk about retrofit looking at the thermal aspects and not so much around the structural and the safety things, which I think was very important. I don't know if there's any questions from the listeners, anything in the chat. Anyone want to ask a question directly to Dimitris?
No, I don't see any questions. They are all still about energy efficiency.
There's a hand up from Nigel Goddard. If you want to maybe unmute yourself, Nigel, if it's current. Nigel, are you there? No, we'll come back to that.
Yes.
Oh, yeah.
Yes.
Right, Nigel.
Sorry,
yeah.
I wasn't able to unmute myself. Yeah, just a very quick question. I'm thinking of reusing the chimney structure in my old Victorian house as a means of putting in whole house ventilation. So pumping air down through, putting pipes down through each chimney and pumping fresh air down through them to each of the rooms. So ventilation without any ducting. So I'm just got a question as to whether that's, drilling into those chimneys is likely to be a structural problem.
It can be. It can be. I mean, once they start working there, they will see how far the feathers the interconnecting plates are still in place. And
Right.
it might not be very difficult to start scratching them with a trowel and start shaking them a bit to see how sound they are. But I hope that they will put a proper scaffolding around that. I hope it is possible. I have seen some horrific scenes in my neighborhood of people just climbing, builders just climbing on the tiles and grabbing themselves around the chimney, trying to pull quickly an aluminium tube down the chimney. And I'm very glad that nothing happened there. Poor neighbors. So that's, I think, if you have a scaffolding or a cherry picker in the first place, inspecting the chimney, that will be your first bit. And then it might be worth employing a structural engineer right at the beginning. It might cost you 100, 150 pounds for a visual inspection without a cherry picker. It might be worth doing also an inspection with a thermal camera on a wet day, because that might reveal any weak joints or any areas where lots of water might have filtered. Any good views of the chimney from sides will tell whether it has started deforming. Sometimes, if you want to make some savings, it might be easier, and if you're not in a conservation area, it's not requested for that, it might be easier to simply wrap cables around the chimney. It's not, of course, a conservation solution, but it braces the whole thing together, and you might be lucky enough to have thick joints between the stones, and you might hide the cables over there. It might be a much quicker solution. It can be done within a couple of days. So that will minimize costs on any scaffolding or in a cherry picker that might be required.
Yeah, I am in a conservation area, so probably not realistic. But,
not realistic. Okay.
Yeah.
As I said, it might be low enough. This bracing might happen low enough so it will not be seen. It might be hidden within the joints. Otherwise, yeah, you have to go for if there's a structural problem. Probably inserting a tube might not be a big disruption in the chimney, but you never know what might happen during that.
Yeah. Okay. Thank you.
Okay.
Great. A comment or question, I don't know, from Ran, easing heritage regs for net zero retrofit. Is that a general kind of comment, Ran, or is it a question? I think you're still mute. Yeah, there you go.
Yeah, it's sort of a comment, and it's maybe relevant to everything being discussed today, which is a lot of councils enforce heritage regulations quite by the letter. And as we push more towards retrofit and look at, what do we do with the windows and all those sorts of things, I feel there's a need to really open up the discussion about how some building regulations need to be eased in terms of accommodating retrofit. And I suspect that will have impacts across all aspects of how we manage historic buildings. So there's not a specific question in there, but I suppose general observation.
Yeah. We used to have this concept of relaxation of building regulations 10, 15 years ago. So you would say that, it's impossible to do otherwise. Well, therefore, let's bend a bit the regulations. It was associated with historic buildings, with accessibility, but I think this concept now has phased out. I mean, it was not an official concept, but it was kind of hearsay among practitioners. But now I think local authorities have taken a harder stance, and they will try to work together with the designer, the professional, to find a solution within the existing regulations. Otherwise, I think the future can be for lobbying. For some regulations are constantly in contrast with what the future of energy retrofit, for example, is going to, then there may be a lobbying by academics and practitioners to change the regulation altogether.
I think your comparison to the access debate is a useful precedent, actually, to show how the industry has managed to accommodate those sort of things in the past. But I do think, I mean, I know, for instance, our local council has a relatively new heritage officer, and they are taking a much, seems to me, a much more picky approach than the previous one did, who was pretty pragmatic in their approach to things. So it can be very fickle. It can depend so much on who you're dealing with. And I think some guidance from the industry on how we integrate with that with net zero is going to be really necessary. I do know Historic Environment Scotland do, are pretty active on that as well.
Yeah. Well, we can pick on that a bit more in the other talks if we can, Ryan. But yeah, I'm sure it will come back to discussion. Okay, thank you very much, Dimitris. That was excellent. And if any other questions come out and you're not here, we can pass them on for discussion.
Thank you very much.
Okay. Better move on. We've got our next speaker and presentation. We've got Dr. Moses Jenkins. He's a senior technical officer at Historic Environment Scotland. So he'll probably have some comments around the previous two presentations and maybe some questions that have arisen. He's going to be talking about latest methods and skills development around existing buildings and retrofit in Scotland. So welcome, Moses, and really happy to have you on board and having your presentation.
There we are. Hopefully everybody can hear me now.
We can, yeah. And we can see your screen as well.
There we go. Right, good. Well, thanks for inviting me along. Today, I have been on a bit of a road show the last few weeks. This is my fourth presentation on this subject in 2 weeks. So it is certainly, no pun intended, a hot topic at the moment when we're talking about retrofit of traditional buildings. So what I'm going to talk about in my sort of 15-minute segment of today is a little bit around measures for retrofitting and a bit about the skills needs which we are now going to have to address if we're going to meet this challenge. So the first thing that I want to draw out is that there is recently, in the last year or two, been very much a coalescing of views around the fact that we cannot demolish and start again. We cannot get rid of all of our existing building stock and build passive house replacements. We don't have the resources to do that. So we're going to have to improve what we have. We're not going to demolish our way to meeting climate change targets. And we shouldn't want to. We should not be thinking in terms of constant demolition, rebuild, demolition, rebuild, which is now, if we look at buildings which were put up in the 60s, they are now starting to come down in significant numbers. So we need to work with the building stock that we have, because apart from all sorts of arguments about resources, which I'll come on to in a minute, these buildings are our heritage. They're about 20% of our building stock. They are part of our history. They are a valued part of our heritage, and we need to be upgrading them and improving them, but not losing that heritage aspect. We should also have firmly in our minds the fact that these buildings are incredibly durable, versatile, and long-lasting. Now, I picked this building purposefully because it is exactly 200 years old. It was built in 1822 as a bank. Since then, it's been a hospital, a library, offices, and it's now a hotel. There is absolutely no reason why we cannot improve the thermal performance of this building and have it last another 200 years. We are dealing here with buildings that will last a very long time indeed if we repair them and maintain them and upgrade them sensitively. Now, I could literally talk for 3 days about methods and materials for retrofitting traditional buildings. We have done a lot of work over the last 10 to 15 years at Historic Scotland on the subject of retrofit. We've installed lots of different measures: wood fibre board on walls and roofs, hemp board under floors, calcium silicate board. We've looked at various materials in the context of putting insulation behind an existing wall lining. So you heard about one of those materials earlier. We've looked at others, including blown cellulose, all sorts of different methods and materials for improving walls, floors, roofs, windows, all the building elements that make up our traditional built environment. And I would say that we have arrived at a range of measures which maintain vapor permeability of traditional fabric, but make considerable thermal improvements. And we've got a relatively well-developed suite of measures now for that. We've produced a lot of case studies based on our research work. So this was a category A, the vernacular building up in the Highlands, where we insulated the walls internally with insulated lime plaster, insulated lime concrete floor, which incorporated underfloor heating that was attached to a ground source heat pump outside the building. Considerable thermal improvements were made to this building whilst retaining its heritage character. And one of our more recent case studies, this category B listed lodge in Edinburgh, Holyrood Park Lodge, where we did the floors, we did the walls, we improved the windows, we did all sorts of work around this building, again, making considerable improvement to its performance whilst retaining its heritage character. But a big question mark remains. I think we've got a reasonably well-developed set of measures, but who is going to design this work when it's happening on the ground? And who is going to install the measures? And crucially, who is going to design them and install them in ways which do not result in thermal bridging, do not result in over-sealing of buildings, do not result in condensation, mold growth, timber decay, and ultimately, in the case of the building in the top left of the slide, that building was made uninhabitable by poorly designed, badly installed retrofit. So we need to look at the skills and the knowledge of who is going to design and install these measures. Now, the bit of building that you can see in the picture there is our training rig at Historic Environment Scotland. We've got 2 of these, and we use these to demonstrate thermal improvements to traditional buildings. So the one that you can see there, we've got underfloor insulation, we've got insulation behind the wall lining, improvements to glazing, and insulated shutters. And we've got another rig which shows improvements to roofs. That is part of a qualification which we are delivering, the Level 3 award in energy efficiency measures for older and traditional buildings. So we've just started delivering that. We've had 29 people complete it so far. And whilst that will help raise the knowledge and expertise of installers and designers, we need a lot more people than just the ones that we can train at Historic Environment Scotland. The Scottish Government have drawn up a skills matrix in relation to retrofit, which sets out the qualifications that people should have who are working in retrofit on buildings, which is an important development, but we need to pick up the pace in terms of who is being trained. We need a lot more people to do this work. I mentioned PAS 2035 there. That's a standard which is designed to improve the quality of retrofit. And again, there are big questions around how many people and the quality of the training which is going into those fulfilling roles under PAS 2035. The last thing I want to consider in my little segment of this webinar is EPCs, because EPCs are the measure of success for this work. Now, we could argue all day long about how appropriate that is. Are there better ways of measuring success? Yes, but the government targets which underpin most retrofit work will be judged as having been met or not, depending on a building's EPC band. So we are going to have to work with energy performance certificates, whether we like it or not. And we are going to have to find ways to make these work well for traditional buildings. We've learned a lot in terms of the EPC process over the years. A few of the headline things that we've learned: a more detailed survey with more accurate measurement, generally speaking, will give a more accurate result, which will often be better for a traditional building. A very important thing to bear in mind is that all retrofit work will need to be recorded. So you will need to be able to prove that you have done it through documentation, photographs, records such as that. Otherwise, it will not be taken into account with an energy performance certificate. And the last point there about paying more for a more detailed survey is an important one, because we found that when we did that, we got a more accurate and better result. Strange things can affect an EPC result. The baffle, which you can see in the fireplace there on the left, we had that retrofitted into that cast iron fireplace, and that gained us 1 SAP point, a whole point for the EPC. But that could be the difference between a band C and a band D. And that, in future years, could be the difference between being able to sell or rent a house. We also found that the secondary heating source that we had in Holyrood Park Lodge, which is the radiant heating panel above the fireplace, that actually cost us points. So removing that gained us 5 SAP points. So there are strange things that can affect an EPC, and it is certainly worth paying a little bit more, in our experience, to get a more detailed survey by somebody who really understands RDSAP, because that can get you those extra few points that could be the difference between meeting a government target or not. I want to end on a positive note. We have done a lot of site-based research using a lot of different methods and materials, and I am absolutely confident that we can retrofit our traditional built environment to make it both thermally efficient and to meet government targets. So all the buildings that you see here are buildings which we have done work to. We can meet this challenge. Traditional buildings can be energy efficient, and they can still be here in 100 years' time performing well. But we do need to think carefully about how we're doing it, and we do need greater numbers of people with the requisite skills and knowledge to design and install measures. If you want to know more, this was by necessity a very quick run through. There is the retrofit guide, which is available free on the internet, so you can download that from our website. And that contains all the methods and materials which we have looked at. And that's my email address there. So if anybody wants to get in touch and ask questions or complain or anything at all, then you can get in touch with me and I'll be very happy to discuss things with you. So I'll end there. I'll stop sharing. And if anybody's got any questions, Julio, I think will read them out.
Yeah, thank you very much, Moses. That was great. Yeah, I have one question here to begin with. How can we overcome the limitations of RDSAP, particularly when modelling historic buildings fabric, which may not be on the database?
Well, there are some aspects of RDSAP that we're just stuck with. It's not a perfect tool by any manner of means. It will be better soon. The next version of RDSAP, so RDSAP 10, when it goes live, will treat traditional buildings better. I got invited along to the working group which reviewed RDSAP, and we have made some improvements. So it will work better when RDSAP comes along. It still won't be perfect, but it is absolutely what we're going to have to deal with. The time to complain and try and find alternatives is finished. We're stuck with the EPC, we're stuck with RDSAP, so we just need to get on with it. We have found, though, that the more detailed survey of a building that you can have done, the better the result will be. And I think that that's something which can certainly help. The short guide has got a section towards the end about energy performance certificates, which will inform that.
I mean, a question for myself in terms of back to the RDSAP thing. I mean, I find it quite limited in the options to begin with. Have you ever experienced actually going down the route of a normal SAP assessment rather than RDSAP?
No, is the short answer. Simply because it just, RDSAP is what is used for existing buildings, and there isn't really much point in carrying out research on SAP in regard to existing structures, because it just wouldn't be applicable on the ground. It would be an interesting exercise, and potentially quite depressing if it showed that traditional buildings were excellent. So yeah, I think, yes, it's not something we've looked at simply because it's not really very widely applicable.
Yeah. A question from Pete, for future EPC retrofit certification, do you have a feeling how this might be managed for work that has already been done? An example, we have a 0.7 U value triple glazing, but don't currently have this certified. So back to documentation and kind of proving that you've done something.
Yeah. I think, and I don't have any firm answer to that, but I think that the only solution really would be to go and have another EPC assessment carried out on the building. The sense I get is that you wouldn't be able to go back and say, well, the methodology's changed, so I'd like to have this incorporated. So I think you would need to have another EPC assessment carried out. That shouldn't be too onerous, though, especially if you use the same assessor as carried it out in the first place.
A question from Barbara, can SAP be used to lodge the EPCs? Similar to my question for existing buildings, the use of SAP is recommended in past 2035.
I'm going to give a kind of Weasley answer to that and say that I can't say for sure what the answer to that is, but I can certainly find out, and I can certainly let Barbara know because I've got her email address. But in terms of everybody else on the call, I'm not entirely sure of the answer to that. I think just off the top of my head, and this may be wrong, but I think it probably can be. It's just that it isn't. It's a more involved process. Therefore, RDSAP is used because generally people don't want to pay very much for an EPC. So I think it probably can be, but I would have to check.
I guess it depends on the level of information you have on the survey that you mentioned. It should be done. A final one from Fang. As you have pointed out, there are some measures adding SAP points, but not good for other aspects. Can you explain the fireplace a little more?
The fireplace. Yeah, essentially what happened was we had the EPC assessment carried out, and we got somebody who very intricately understands RDSAP, and we said, right, you know, we're going to pay you a reasonable sum of money, and we want you to go around and find every possible point that you can scrape together with relatively straightforward measures. And one of the things that came out was by there was a cast iron fireplace in the open fire, which didn't have a baffle. So a baffle is a little metal plate which can open and close, and it sits just at the start of the flue within the room. And our energy performance man said, well, if there was a baffle there, you'd get 1 point. So we had a baffle made and we had it installed, and that got us 1 SAP point. Now, whether that's something that the majority of people will do, I don't know. But if somebody was 1 point away from a band C and they really needed that extra point to meet government targets, then it would certainly be a relatively straightforward thing to do. So, yeah.
There are 3 questions here, but I think we should move on to the next talk, if I may, and I'll try and pass these questions over to you, Moses, if I can. And if you're able to answer them in an email or something, I can pass them on if possible.
Yeah, no bother. Just email them over. Yeah, sure.
Great. Thank you very much, Moses, as always. Great presentation.
Great. Thanks very much.
Thank you. Okay. Great. I think we'll move on to our final talk. Try and kind of meet our times here. We've got a double act again. We've got Michelle Mundie, who's a Principal Officer for Housing and Regeneration Services at Glasgow City Council, together with Barbara Lantschner, Associate Director at John Gilbert Architects, and they'll be talking about whole tenement block retrofit to high energy efficient standards. So over to yourselves. I believe Michelle is talking first. Michelle, are you there?
Can you hear me?
Yes, can hear you, yeah.
Okay. Sorry, you had me on mute there, and I couldn't get it off mute. So hello everyone, my name is Michelle Mundie. I'm Head of Housing at Glasgow City Council. Is my camera on? There's another thing. Yeah.
It is, yes. Yep. Yes, I can see you and hear you.
Yeah, okay. I have a space background, and I'm not coming to you from space. I'm actually coming to you from my phone. And the reason I'm telling you that is because my mum has already tried to call me once, and she might try to call me back. So I apologise in advance if that's the case. I've been asked to talk today to you about Glasgow's tenement retrofit, and specifically the EnerFit project that we assisted with at the Road with Southside Housing Association. And what I would say is I'm not a technical person. I'm a housing person, but not technical. So I'm going to bring you the sort of other side, the practicalities of delivering things rather than a technical aspect of it. And I'm going to leave the technical part to Barbara. So before I talk about that, I'd like to just talk through some context about the tenements in Glasgow. So in Glasgow, we've got about 3,001 dwelling houses, and of those, approximately 134,000 are owner occupied, and about 59,000 of them are privately rented. And as you can see from the heat map on the screen of the Clyde metropolitan area, there's a concentration of flatted properties within the Glasgow area, and that's about 75 to 80% of our stock being flatted. And of these 301,000 dwellings, approximately 21% of them are classed as pre-1919. So Glasgow is estimated to have more than about 70,000 tenements, some of them pre-1919, some of them not. And if you compare that to Scotland as a whole, Scotland has about 182,000 tenements. So Glasgow has quite a high proportion of them. The buildings have a very significant cultural, historical and urban value, and as Moses has already talked about, but they also have the poorest thermal performance, having solid walls and little insulation. And many of the properties are in the private rented sector and face significant common repairs issues. So solving this problem is a key priority for the City Council and its stakeholders. Going to the next slide. Before we even talk about retrofitting though, there are some particular challenges around this type of house. And that is that there is substantial repairs and improvements needed to the pre-1919 buildings. My team is in charge of working with owners to carry out voluntary tenement repairs, and where they fail to do this, to impose statutory repair notices to get the work carried out. The number of these is increasing, and the value of works is also increasing, with some tenements requiring work in excess of about £1.5 million just for one block, and that's before any retrofits applied. There are issues around the responsibility for repairs and the maintenance of communal parts. Sometimes this is the owners just don't want to participate. Sometimes it's a title deed issue. An example of this is where the ground floor shop has a responsibility for about 80 or 90% of the costs and refuse to carry out repair and improvement work to the upper floors. And then there's the impact of the private rented sector in areas with poor housing condition, so absentee landlords and empty homes. Private landlords are not eligible for more than one measure with the loss of the energy efficiency funding. So if they've got a large portfolio, they're expected to fund themselves, and they don't. There's also a need for block insurance in common properties, and there's so many properties out there that just don't have that. And the poorest property conditions are associated in many cases with negative equity and affordability issues. The owners simply cannot afford to do the repairs to the property, never mind also doing energy efficiency works. So how do the owners meet the cost of retrofit? And I don't have the answer to that, but I just thought I would pose that question. There is a role for factors in executing common repairs and doing ongoing maintenance, but that does depend on the owners paying the factoring fees. And then for housing associations, there is the cost to meet EIS2, so they don't have to just meet a standard D or a C. The housing associations are having to meet an EPC band B. And as you can see from all that, there is interventions required from the council. A recent report from the City Region estimates that the cost of bringing the pre-1919 housing stock in Glasgow up to the required energy efficiency levels would be in the region of £9 billion. So there's a cost issue there as well. And just move on to the next slide. If we didn't intervene as a council, we would continue to see the physical deterioration of the built form. And as a council, we have a limited budget, so we can't do it all. There's the impact of climate change to take into account. Extreme weather events are causing further deterioration of tenements through storm damage or flooding. There's the increased cost of repair. The longer that the work is ignored, the worse the problem gets. There's also the issue of hyperinflation, which will be pushing the cost of some work out of people's reach. And if the stock has to be demolished, which we don't want to happen, but in some cases maybe the cost is just getting too high, we are going to see a reduction in much needed housing stock in the city at a time when we're predicting population growth. And then there's the loss of the heritage, because Glasgow is famous for its tenements and we absolutely want to keep our tenements. There's the impact on health of the citizens, and there's affordability, especially with rising gas prices. The cost of heating some of these buildings will just then become unaffordable for some residents. And that brings us on to Mundie Road. If we go on to the next slide, this is Nidri Road. Nidri Road was brought to the council by Southside Housing Association, who managed to buy 7 of the 8 flats from a private landlord and then secured the remaining flat from the remaining owner, which meant that they had ownership of the whole tenement. The tenement required some work. If we go on to the next slide, you'll see exactly what I mean. And because it was empty, it's really unusual to get a whole empty tenement. So Southside approached the council with a view to doing something a bit different with the block. They had just been learning about passive house and asked if we would consider it as a passive house retrofit. Our answer was, of course, no. But at the same time, the council was looking for projects to put forward for the Scottish Funding Council's Climate Change Collaboration Fund, being led by the universities, and we put this forward as a possibility. The bid, led by Ken Gibb at the UK Collaborative Centre for Housing Evidence, was successful, and we set about creating the first pre-1919 passive house retrofit, or enerfit, project in the UK. We think it's the first one anyway. We're claiming that. And you will see from the picture of the property that it was in a bit of a state and it needed a lot of work, not only to address the energy efficiency, but also to carry out the necessary repairs needed to maintain the building for another 30 years, including the stonework. Excuse me. Yeah, I think we're on the next slide now. The project looks at the challenge of reducing carbon emissions in pre-1919 tenement flats. And as I said before, the block was empty, so there was no need to decant the tenants. One of the challenges going forward is how are we going to be able to do some of this work with the tenants in situ? So the project aims to explore and monitor the design, specifications and build stages, appraise the various choices available to the Housing Association and the architects and other built environment professionals, identify key financial, technical and policy drivers affecting choices, identify the barriers to performance, for example, the availability of construction skills and knowledge, and the supply chain for appropriate materials and components, measure carbon reduction and make technical assessments of different insulation, heat and power solutions, and monitor the financial implications of the project and determine the wider policy implications. Questions that we asked ourselves were, can we carry out an energy efficiency retrofit of a historic building? Well, if it's a passive house enerfit, then possibly. And we were attempting to dramatically improve levels of airtightness and energy efficiency. Can we develop a strategy for achieving net zero? And this project is a prime example of taking a fabric first approach to achieving net zero, taking a comprehensive approach to minimising energy use and maximising comfort. Can we reuse a vacant and derelict building? Absolutely. Tenement had been vacant for over 2 years prior to the work commencing, and this was due to the urgent and necessary repairs that were needed to the building. Will renewables work? So as part of the project, 4 flats were having small gas boilers installed, and the other ones were having heat pumps installed. So the part of the project was to look at the difference between the two. And what are the local sustainability issues and standards? We are looking at, can we replicate this across the other 73,000 tenement flats in Glasgow or indeed Scotland? And does it address fuel poverty? This was a pilot project. It was a COP26 demonstrated project, and it had never been done before, as far as we know. It is about gaining understanding of the issues and determining whether we can replicate it across the city. The project team, I'll just move on to the next slide. Project team was a collaborative retrofit demonstrator project. As I said, it was led by Ken Gibb, But the other key partners were Southside Housing Association, Glasgow City Council, John Gilbert Architects, CCG Contractors, the Scottish Government, and there's various other consultants as part of the design team. Just move on to the next one. Yeah, so what is EnerFit? EnerFit standard is a passive house standard intended for refurbishment projects. It allows for more wiggle room compared to traditional standard to accommodate retrofit challenges, while still achieving the comfort and performance of passive house. The EnerFit standard can be achieved in one of two ways, based on the requirement for heat demand or in the requirements for individual building components. Both methods rely on passive house principles to improve energy efficiency. And just before I pass you on to Barbara, I'm just going to say that the project was principally funded by Glasgow City Council and by Southside Housing Association, who owns property, with additional grant funding coming in from the Scottish Government for their social housing net zero fund. CCG started the retrofit work in April 2021, and I don't think it's quite off-site yet, but Barbara will be able to confirm that. But it was featured as part of the COP26 European Union side events, and it hosted site visits for delegates as part of COP26. So, Barbara, I'm just going to pass you on. That's okay.
Sure. Well, thanks very much. That was a great introduction for the project. Just a very quick introduction for myself. So I'm, again, my name is Barbara Lantschner. I'm an associate director at John Gilbert Architects. I've been working on many deep retrofit projects in the last years, and this is one of them. I've been more involved at the beginning of the project, and when we first proposed EnerFit to the client, to Southside Housing Association, and then that became a bigger partnership, as Michelle was mentioning just earlier. So the question here is, this was a pilot, and I'm going to explain a little bit of how did we started this and what should be looked at first at the very beginning on a retrofit project. So the first thing, because we are trying to decarbonize properties, and because it's very likely that the systems will run on electricity on some sort from renewables or other sources, it will be electricity. So if we're not improving the fabric first, as first strategy, it's very likely that the energy bills are going to be high or higher than expected, and that's a burden for the residents and building users. So we have to look at the improvement of the fabric first. And this is a very nice graphic and the summary of the measures that we have proposed for this project. And you see some of the measures are passive measures, some are active. In terms of the fabric, we analyzed at first. It includes external wall insulation, internal wall insulation, ground floor insulation, and loft insulation. And I'll talk about the active systems later on. And before we actually looked at the fabric improvements, we analyzed the existing building. We analyzed what's there. We did a lot of measurements. I won't have time to go through that, but if you're interested in building performance evaluation, please contact me, because we had conducted a very long list of in situ measurements to deeply understand how the existing building was performing. The walls were uninsulated, solid sandstone walls, as you can see in the picture on the right. Floors, suspended ground floors, timber floors were uninsulated. It's a hard to treat property, existing EPC of 55, 59, and of course not EIS compliant. And the questions that we are trying to make when we are now doing this kind of projects, retrofit projects, is this building heat pump ready? Is it, I'm saying heat pump because it's likely we're going that direction, but it could be all the other systems. Would it be reasonable to install a heat pump as you see it in the picture on the right? And for us, the answer after doing this tests were no. We had to first maintain the existing fabric to bring it to make it retrofit ready, and we had to prepare strategies that were suitable for this kind of buildings. There were some opportunities and challenges for the fabric there. It was a compact, relatively good form factor, so compact building in terms of energy, but it's still heavily overshadowed. Small southeast facing windows, a large amount of northwest facing windows, and significant unavoidable thermal bridging. So we looked what we did a good amount of building performance evaluation studies before we started the projects to understand the building. We did modeling, hydrothermal simulation, thermal bridging simulations, and we used PHVB to prove compliance for NFIT. We then prepared a very detailed and bespoke design for the fabric, and that included a hybrid approach, internal wall insulation for the street-facing elevation to respect the existing features, and external wall insulation for the rear elevation to be able to protect that elevation better, to be able to mitigate thermal bridgings easier, and use other type of insulation materials. And then we installed loft insulation, so mineral wool, and a mix of mineral wool and wood fiber for the ground floor insulation. And a key aspects for NFIT, air tightness measures throughout. And that's key because that's a key part for NFIT to meet the NFIT standards. In terms of the suitable active systems, we looked at a large amount of systems that we could possibly install here. Unfortunately, solar, PVs, and CHPs were not suitable for this kind of project, which started to narrow the type of systems that we could install. Available options then were heat pumps, some sort of air source heat pumps or ground source heat pumps, compact or not. And we explored the different systems that could be suitable for this at an earlier stage, and that could also meet the NFIT targets. We didn't explore heat networks because it was outside the scope of the projects, but I think it would be really interesting to look at this in future projects. In terms of ventilation, it's not only about energy, so we really focus on ventilation mainly because NFIT, that's a key aspect for NFIT to ensure comfortable, warm, and healthy buildings, which is key for that standard. And we looked at centralized and decentralized systems. In other projects, we look at demand control systems, but we had to install an MVHR for this project to comply with NFIT standards. The final specification for the active systems, which was prepared for the fabric, adapted to the fabric design, and it was compatible with the proposed air tightness target, was two type of heating and domestic hot water systems. The first one, it's an air source heat pump in the ground and first floor flats, providing heating and domestic hot water. And the second one was high efficient combi condensing boilers. This was prepared a couple of years ago. We now are trying to avoid gas boilers to be able to decarbonize properties. But at the time, the technology that was available there was suggested that this was the two most reasonable options. In terms of ventilation system, we propose a centralized MVHR system. And we also installed a wastewater heat recovery system, and all of this combined with smart controls. A key aspect of the project was to work on the human factor from the beginning. We prepared documentation that was easy, well explained for contractors, and user-friendly systems with easy to use controls and and we also conducted toolbox talks for contractors to be able to explain what the key elements were for a project of this type. And we also prepared quick start guides with easy to and bullet points and explanations for maintenance and other recommendations for residents on how to use these systems. I won't have time to go through the energy modeling, but I will say that that was linked to what Moses was mentioning before. RDSAB, it's a compliance tool and should be used as a compliance tool, not as design tool. So we used RDSAB and SAB to prove compliance in terms of building regulations and government's targets, and PHPP as a design tool to minimize performance gap risks. And this helped us to carefully define fabric and systems. And the last thing, just a couple of conclusions. So retrofit, can have a huge impact and in the contribution to in the path to reduce CO2 emissions, but if done correctly. So we do have to carefully prepare retrofit strategies, this being staged or not. And they are out there very interesting standards and robust standards that minimizes performance gap issues. For example, the ACD standard Passive House Enerfit past 2035. There's a great opportunity to develop a Scottish retrofit standard for tenements. We're currently working on that, and we are really interested to scale this, to prepare a scalable standard for tenements. And there are some pictures on the right of what we're currently working on. And the existing property factor scheme that Michelle was talking about, that we should be using the existing schemes and merge that with energy efficiency, because the scheme is already there. And we have developed within the practice tenement toolbox that it's trying to link energy efficiency and conservation, maintenance and energy efficiency. Retrofit, the last thing, retrofit, it's now becoming more relevant than ever with the increasing energy costs, the Ukraine invasion, and so on. So everything, it's pointing out this direction. We do have to carefully prepare strategies that are leading us to the right direction. And other things that we are looking at are embodied carbon calculations and scalable retrofit solutions. The question is, how would that final Scottish retrofit standard look like? And that's me. Thanks very much.
Thank you very much, Barbara. Michelle as well, thank you very much. Great presentation there. I don't know if there's any questions. We might be able to squeeze one if anyone's got one. But as always, if there is a burning question, we could probably direct it back to yourself and by email, if that's possible. No, doesn't look like there's anything in the chat, but thank you very much. Okay, well, I think, well, thank you very much to everyone. This has been really interesting, very different perspectives around building retrofit, not just the thermal, but also the structural and looking at conservation, etc. So I think it's been very, very enlightening. Hopefully you've all enjoyed it. I just want to thank very much the people at ETP, Tom, Dave, Ewan and Saria for organising all this. But I believe Dave's got some final words there. He just wants to wrap up. So thank you very much, everyone.
Yeah, thanks, Julio. We've maybe got a very last minute question that's just came in as you were speaking to Barbara about whether you think it would be possible for this to be replicated on a large scale, or an even larger scale, I guess.
I think Enerfit, it's possible to replicate, but probably on a step-by-step approach, not all in one, because as Michelle was explaining before, the 8 flats were void, the whole close was void, and that's a very unique situation. This works on a occupied property or in a mixed tenure property, I would say a mix of both, it's much more complex and definitely more difficult to solve. But I think if we plan it, the key word there, it's plan. If we have a retrofit plan and a longer term plan, I think it's possible to do. And within the existing climate crisis, I think it's definitely worth it to plan this ahead.
Great, thanks, Barbara. And just to echo what Julio said, big thanks to all the speakers. Demonstration is everything in this area, and we've had some really great examples of demonstration today. So thanks very much for that. And thanks to Julio for organising some of the speakers, and as Julio says, the ETP team, Syra, Tom and Ewan for helping put all this together. You can view all that all over again if you really want to. Of course you would want to, why wouldn't you? On ETP's YouTube channel, so that'll be up on there in the coming days. But other than that, thanks to everyone for coming. We had a really good turnout, so that's great to see. And watch this space and keep on engaging with ETP for future events that we'll have planned in the coming weeks and months. So just a big thank you to everybody, and hope to see you again next time. Thank you very much.